Hello, I'm Illustrious Elucidation. I'm a chemistry graduate and now I would like to try again explaining the stone parts with the chemistry knowledge that I have. The party continues and the crafting still won't stop. It's decided that Sino focuses on the engine design while Senku focuses on the fuel to power the engine, gasoline. There is no oil deposit in the area, so Senku must improvise. Senku's solution? Use garbage, literally. While he meant organic waste, and that includes leaves, food waste, scraps, and poop. The gas that is generated from that is then used in what Senku called Fischer-Tropsch process. The crafting continues until new Perseus with its overpowered engine is finally finished, but that's not my really business as chemist, isn't it? My job here is to explain that Fischer-Tropsch thing, or FT for short, and the process before that. It appears that Senku uses fermentation of organic waste to make ingredient for the FT process. The organic waste is decomposed and fermented by anaerobic bacteria, so it produces gas, and the one we are interested in is methane, CH4. I want to point out that Senku said biofuel. Usually, biofuel refers to liquid fuel produced by biological or organic stuff. And usually, that liquid fuel is bioethanol, obtained by fermenting sugary stuff or maybe cellulose-based stuff. Or biodiesel, made of capping of the ends of oil molecule with metal. While that's what some organization from USA calls it. Senku, as usual, lives dangerously by calling stuff not by its usual name. Remember the carbon fiber that's made of paper? What Senku makes is usually called biogas, not biofuel. The gas methane is combustible, but Senku went beyond that, maybe because the engine that Sino makes is only compatible with liquid fuel. So in chemistry terms, Senku combines those single carbon atoms for methane into a longer string of carbon, usually 4 to 12 in length, and that's gasoline. Usually the ingredient for FT are carbon monoxide and hydrogen, which is pretty much wood gas or syngas that powers the ship and motorcycles, from around chapter 170 to 180. Seriously though, Senku, why don't you just borrow the motorcycle engine and chop wood again? Did the engine break in 7-year time skip and everyone is too busy to repair it? Anyway, Senku may get around this ingredient problem by using the steam reforming on the methane. The other important aspect of FT is the catalyst. Usually, the catalysts employed for FT are either ruthenium, cobalt, or iron. Oh look, iron, easy to find metal, isn't it? I think it's just me and my opinion. It's kind of ironic that in the last chapter we got exotic metals like nickel, niobium, molybdenum, etc. Only to be not used here. Anyway, the iron as a transition metal can bind carbon monoxide molecule, just like nickel in previous chapter. The iron binds and separates the C and the O, and hydrogen hydrogenates them both. H2O is released and CH2 stays there. More and more CH2 are bound to the iron until some of them probably react with each other, making carbon-carbon bond, and that means we successfully making the chain longer. Repeat this a few more times until we have 4 to 12 carbon chain. That's gasoline. The total reaction is this. For gasoline, we won't end somewhere between 4 to 12 of course. That was the basics of FT. There are some intricacies of this FT process, but this video is just some demo video, not a super serious lecture from an inorganic chemistry professor, so I'll just mention it briefly. Temperature control is important in FT. Usually higher temperature FT, like around 350 degrees Celsius, makes shorter chain compounds like gasoline, while lower temperature FT makes longer chain compounds like waxes. Of course, we want to avoid one carbon chain compound. That's just methane, we're back to square one. Also, there are a bit of consideration on the hydrogen to carbon monoxide ratio in the syngas that's the best for the process. And for the syngas, it also shouldn't have sulfur in it, because that poisons the iron catalyst. Furthermore, as a trivia, this FT process is kind of the opposite of the cracking process Senku did in school before he was petrified. The cracking breaks long molecule into 4 to 12 carbon molecules, the FD combines one carbon molecule into 4 to 12 carbon molecules. And there we go, we have gasoline. Wait, does that mean we got a green gasoline? Well, yes, if you make it from biogas like Senku did. Unfortunately, because of economics, the usual ingredient or feedstock for FD is syngas from coal. So, using fossil fuel to make another type of fossil fuel. Also, because of economics again, if processing petroleum is cheap, as in oil price is cheap, then there is no reason to use FD. Until we run out of petroleum, I guess. In conclusion, Senku obtains gasoline or liquid fuel from using fermented waste that becomes biogas full of methane. After processing the methane and steam into carbon monoxide and hydrogen, the combined gas is ready for Fischer-Tropsch process. With iron as the most likely catalyst and some off-screen temperature control and feedstock composition control, the carbon atoms are chained together into longer organic molecules. Senku's gasoline uses waste as renewable resource, but real-life FD usually uses other cheaper feedstock that is not so green. That's all I have for now. I make more in-depth chemistry explanation for Dr. Stone, and once I run out, maybe other shows or title. If that's what you're looking for, why not you join my right here and subscribe to this channel? Thank you!